In this video, we're going to work with applications using systems of equations. I'll give you a few moments to read the problem, and then we can start working with it. The key, one method that works is to set up a table. And on this table along the left-hand side are the various items. So we have the peanuts, the cashews, and our new mixture. They didn't name what the mixture is. Then we have some information. The problem did tell us that the cost for each item, the peanuts, the cashews, and the new mixture. We don't know how many of the peanuts or the cashews to use, but we do know how many pounds total, and then we can find an actual value. So let's fill out the table. Then once we fill out the table, that'll help us set up our equations. So the peanuts are $7 a pound. The cashews are $14 a pound. And our new mixture is going to sell for $9. Remember, when you are working with systems of equations with applications, the mixture can never be less than $7 or greater than 14. It can't be any bigger than those particular items. So we don't know how many pounds to use of peanuts, so we can just assign this the letter P or X, whatever letter you want to use. Cashews will be C. But we do know how many pounds we're going to make of this mixture, which is 245. So we can fill that in. Now the value can come from the cost per pound and the amount used. So when we do these types of problems, applications, we multiply going across and we add going down. Put that plus up here. So to work across, we get 7p, 14c, and then 9 times 245 is 2205. So now, to work with these equations, we have amount used, so the amount used and the value, and we have two equations with two unknowns. So we can set this up. P plus C equals 245, and the second equation, 7p plus 14c equals 2205. So these equations, P plus C equals 245, came from the amount used, and the 7p plus 14c equals 2205 came from the value. So at this point, we could either use substitution or elimination. I'm going to use elimination. So we're going to multiply the top by -7. I could have done it by -14 if I wanted, but I just picked -7. So our new equation will be minus 7p minus 7c equals minus 1715. Make sure that when you are multiplying across to use elimination, that you do multiply each term, and that if you are multiplying by a negative, don't lose that negative. And then we can simply bring over the second equation. At this point, the 7p and the minus 7p go away, and we're left now with one equation to solve. This gives us 7c equals 490. Divide both sides by 7. So c equals 70. Now, we know that c equals cashews, but you should present your answer with units, so pounds, and what those units correspond to of cashews. So we know that we were going to make 245 pounds of this mixture, and if we're using 70 pounds of cashews, that leaves us 170 pounds of peanuts. So our answer includes both the cashews and the peanuts. The next problem is going to deal with finding the number of tickets sold for an event when you know how much you collected, the cost for each ticket we can find for each individual. So if 125 tickets were sold, making the venue $1,150, we want to find out how many adults tickets were sold and how many children's tickets were sold. From the problem, we know that the price for an adult ticket is $2 and the price for a child's ticket is $1. We don't know how many adult tickets were sold, so we'll use the letter A and letter C for children, but we do know that the total combination was 925. As with the previous problem, we multiply going across and add going down, so we can create our second equation simply by multiplying across. In this instance, we know the total amount sold. So in this instance, our two equations will be A plus C equals 925 and will come from the 2A plus C equals 1150, the cost of the tickets. So to come up with our two equations, A plus C equals 295. 925 would be a better number. And 2A plus C equals 1150. This systems of equations could be solved by elimination, but we'll use substitution this time. So I'm going to take that first equation and I'm going to subtract C from both sides. So that'll give me A equals 925 minus C. You could have written this as C equals 925 if you 925 minus A if you wanted to solve for C. Doesn't really matter. So then we'll take this 925 minus C and we will substitute that for A. So we get 2 times 925 minus C plus C equals 1150. We want to do our distributive property. So we'll get 1850 minus 2C plus C equals 1150. So now all we need to do is combine and simplify. I'll put that over here. So we'll get 1850 minus C equals 1150. Now at this point, that minus C might be of a concern, but let's just keep working the problem. Obviously we can't sell negative tickets, but we'll see what happens. So if we subtract 1850 from both sides, we'll see that 1150 minus 1150 minus 1850 gives us a minus 700. So minus C equals minus 700. Divide both sides by -1. So C equals 700 children tickets. And since we know that there were 925 sold, we can subtract that and get 225 adult. The last problem is going to deal with motion. So we have Julie and Eric row their boat at a constant speed, 60 miles downstream for 6 hours. They are helped by the current. Rowing at the same rate, the trip back against the current takes 10 hours, same distance. We want to find the rate of the current, and we want to find their actual rate in still water. Now, thing to remember when working with rate, time, and distance problems is we have to remember that rate times time equals distance. So in this problem, we're going to multiply to go across. Now, first thing we want to think about when working with these types of problems is coming up with our unknowns. So we're going to set B will equal the boat, and C will equal the current. Use whatever letters work best for you. Now, if they're going downstream, the current is going to work with them. It's going to actually add to their speed. So we'll get B plus C. This is a little unusual. We're going to have two unknowns, but in one column. And it took 6 hours to go downstream, and oops, let's put the S there, and they went 60 miles. Now, we're making the assumption that the current didn't change and that their rowing didn't change either. Ideally, that's not always going to happen. So if they're going upstream, instead of the current working with them, it's going to work against them. Hence the reason they took 10 hours to go the same distance. Now in this problem, we have two equations. So we have 6 times B plus C equals 60. The second equation is 10 times B plus C equals 60. Now I wrote these horizontally because we can actually do some simplifying. There's nothing preventing you from taking the 6 times the B and the 6 times the C, and the same thing, the 10 times the B and the 10 times the C. Let's get rid of that positive and make it a negative. But since the numbers work out nice, we can actually take the left side and divide both sides by 6, and that'll give us B plus C equals 10. The right equation, divide both sides by 10. That'll be B minus C equals 6. Now these numbers that were chosen for this problem, they divide out nicely. If they did not divide out nicely, then you can just leave it as a decimal. So now we can take the second equation and write it under the first, making sure that you have subtraction for that C, and the C's go away. So 2B equals 16, or the speed of the boat is 8 miles per hour boat. But the problem also wants to know the current. So we can take any of these equations. I'll take the first one. B plus C equals 10, and I'm going to substitute 8 for B. And then simplify, solve for C. So C equals 2 miles per hour for the current. And that's our answer.